Right. Recently, the World Health Organization made a statement that they now consider mobile phone radiation to be probably carcinogenic or possibly carcinogenic. Anyway, this is quite a piece of news, and everybody is saying, "Oh, it can't possibly be carcinogenic because the quantum energy, the photon energy from radio frequency electromagnetic fields, which are about 2,000 megahertz frequency, can't interact with molecules because the molecular energy levels, even for rotational energy, are too high for any quantum effects to take place. So what you just have is dielectric heating, which they say can't possibly harm anybody. But there is actually a way in which radio frequency energy from mobile phones can cause cancer. And the way it does it is by altering the tracks of fast electrons which are generated in the body by natural background radiation. There are two ways that you can get fast electrons generated in the body from natural background radiation. The first is from external gamma radiation, which interacts with tissue to produce photoelectrons. These photoelectrons are emitted when the gamma radiation from the Earth's background interacts with elements in tissue, mostly water in fact. So electrons fly out and you get these electron tracks. And the other way is from internal radionuclides, which are beta emitters, like strontium-90, cesium-137, but also natural element potassium-40, which is said to have the highest proportion of internal radiation dose to human beings as a result of these beta particles which come off. So the body is all the time suffering the effects of fast electrons which come out of the particles and zoom. Anyway, the point is this, that if you put an electron in an electromagnetic field, or indeed in a magnetic field, you cause it to shift. There's a force on it called the Lorentz force. And in fact, this is how a television set works, the old-fashioned television sets anyway, because you had a cathode ray tube and you fired an electron down, you had an electron beam which you fired down the tube, and you caused it to wiggle, and then you could make it wiggle on the television screen, and that produced pictures. And the way you made it wiggle was with putting electromagnetic field across its path. You put a very high voltage across its path, or you put a high magnetic field across its path. But the point is that it was the Lorentz force that causes the electron to wiggle about. Now, the effects of ionizing radiation are proportional to energy density. So if you have very high energy density in tissue, if you have lots and lots of ions formed at one point in tissue, then you can have much bigger damage to the DNA, because you can cause a double strand break, which is much more difficult to repair, or which is almost impossible to repair, in fact, because you've broken two strands of the DNA and they don't know how to get back together. Because both of the sides of the DNA, which are normally complementary, are both broken, then the new DNA doesn't know which base to put back onto the other strand, because both strands are broken. If you've got one strand broken, if you have an effect on one of the genes on the DNA, one of the bases on the DNA, then the copying processes can come along and it can look at the other side of the DNA and it knows which one to put back in, so it can repair it, you see. And in fact, we've got this repair mechanism because we live in I believe, because we live in a radioactive environment. So the reason that we live as long as we do is because of our repair mechanisms. But that's, by the way, that's another thing. We're talking about mobile phones now. Okay. Well, it's simple. There are certain... Well, I should first of all say that we know that high energy density causes more cancer or more genetic damage than low energy density because of alpha particles, which are another kind of internal radionuclide emission. Alpha particles are very short range, so they deposit their energy in a very small amount of tissue. The range of an alpha particle from uranium, for example, is about 4 cells. So all of the energy from the alpha particle decay occurs in 4 cells. And we know from experiments that are done with cell cultures and experiments with alpha particles and so on, that alpha particles are much more likely to cause double-strand breaks. And so actually even the current radiation risk model allows for this by adding a factor of 20 for the dangerousness of alpha particles. So if you have an alpha particle emission and it gives a certain dose, you multiply that dose by 20 to get what's called an equivalent dose in sieverts. Electrons only carry a factor of 1, so if you get a dose from an electron emitter like a beta emitter, then or even gamma radiation, then the dose is the same in grays as it is in sieverts. Okay, so we have established that energy density is very important in causing cancer, in causing genetic damage, which leads to cancer or chromosome damage and so on. Anyway, so if we now go back to the mobile phone radiation. Now, the current limits that are imposed on mobile phone radiation are done in terms of energy, heating energy, joules per kilogram. And the limits are about, I think, 1.6 watts per second per kilogram. So if you hold a mobile phone to your ear or to your skin, the mobile phone shouldn't give you more than 1.6 watts per second per kilogram of tissue. Of course, lots of people are suffering brain tumours on the side of the head where they use the mobile phone. But the current reasoning is that there's no mechanism to explain this. So the argument is that it can't really be the case. It's silly, of course. I mean, we don't need to go to theoretical science to try and discover something which is actually shown by experiment. But anyway, it does seem we do have to do that nowadays. And so for this reason, although there's a huge amount of evidence that mobile phones cause brain tumours and lymphomas and salivary gland tumours and acoustic neuromas, a whole range of cancers, the WHO are not prepared to say that it is a carcinogen. They say that it's possibly a carcinogen. Anyway, that is a breakthrough. But here I'm now going to explain how it works. This is the mechanism. When you put an electron in an electromagnetic field, so like the beta particles in your head, where we've all got these beta particles because of natural background radiation, also a lot more because of fallout and because of Chernobyl and cesium-137 and all these are all beta emitters. So they're all inside your body all the time. There's electrons whizzing about. There seems to be some interruption. Some Latvian person has just... That's it. Okay. So the electrons are whizzing around inside your head. And what I'm saying is that the mobile phone radiation is causing them to wiggle. So there are equations which we can use to deal with this. These are some equations here. These are equations which enable us to calculate really quite simply. This is just schoolboy stuff, really. That if the speed of the electron as it leaves is about half of the speed of light, so it's going very fast. And if we just put the normal electromagnetic field on that, the kind of electromagnetic field you would get from a mobile phone is about 2 times 10 to the minus 6, 2 microteslas. Yeah, that's right. So if we put that magnetic field on the electron, we cause it to shift very, very slightly in its path because it's going very fast. So, and when you do the calculation, you find that the radius of curvature of the shift in that electromagnetic field is about 260 meters. Well, that's not going to make much difference because the actual track length of the electron in the body is not very great. It's about 400 cells for strontium-90. But the point about it is this, is that as the electron passes along its track, it slows down. It gets slower and slower and slower, and eventually it stops. And if you look at cloud chamber photographs of electron tracks, you find that at the end of the track they start to go wiggly, 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 and then they sort of curl up in a little ball. So they deposit an awful lot of energy at the end of their track. So the question is, what level of energy can be borrowed from an external electromagnetic field? And it turns out that it's enormously high, because if you do the calculations and work out what the radius is, what the velocity is for the electron associated with a radius of 100 microns. 100 microns.
Bring it
is
a bit
about
forward. It was a bit far.
100 microns is about 10.
Up and down a bit, so they can read really what you've done. A bit down, closer, and now a bit up, higher, 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 and a bit higher. That's it.
Okay, so 100 microns represents about a cluster of cells, if you like. And just arbitrarily, we're going to have a look and see what I did. I was have a look to see what proportion of the track length is associated with that. And it turns out to be some proportion of the track length. I won't bore you with what it is, but it's some fraction of the track length, right at the end of the track length, that has the velocity that's slow enough for the electron to be perturbed and whizzed around by the electromagnetic field. But the electromagnetic field energy is enormously high, absolutely colossal. This is what's not what you don't realise. What people don't realise is that if you take the electromagnetic field energy that you're permitted to have from a mobile phone, and you convert it from joules per second per kilogram, in other words, watts per kilogram, if you convert it into electron volts, and it's the electron volts end of things which are causing the bond breakages and so on, and are causing the effects on the electron. The energy is, what is it? It's 10 to the, yeah. This is it. That the energy associated with an electromagnetic field from a mobile phone in your tissue is 6 times 10 to the 18 electron volts per second per kilogram. 6 times 10 to the 18. I mean, this is just unbelievably enormous number of electron volts. Hugely greater than the number of electron volts that are created by the beta track. The beta track electron volts is very, very small. So, but we know that the beta tracks actually cause cancer. So you've got like these tiny amounts of energy associated with cancer from the electron, and huge amounts of energy which can interact with the electron for this small path length. Anyway, when you multiply those two together, you find absolute certainty that this is the effect that's causing the increases in cancer. And it's a very simple mechanism. It's a mechanism that a schoolboy could have figured out, and maybe did.
If they were given the right school.
Yeah, if they were given the right school. Anyway, so we have figured it out. And the answer, of course, is that theoretically it's possible. Of course, maybe it doesn't work. So let's go and see. Obviously, the experiment to do is to do an experiment with cell cultures or some endpoint that looks at chromosome damage, some animal maybe, mouse, poor old mouse, and put them in and fill them up with some beta emitter, you know, cesium-137 in the solution of the cells, and then whack them with microwave radiation at 2000 megahertz. So there we are. That solves the problem of the mobile phone cancer mechanism. Thank you very much for listening.
Yes, indeed. We have time for breakfast now.